Okay, we are continuing on October, November 2024, paper 41. We start at question 9.
So almost finished.
You will louder,
Yeah, this one almost finished already.
can hear you. Have you found the paper?
Yes.
Okay, let's go to number 9. Fluorine 18 decays by beta plus emission with a half-life of 110 minutes. State the name of beta plus particle. What is it?
Positron.
Okay, good. Positron. Show the decay constant of fluorine. This one is giveaway mark. Go to formula sheet or you've forgotten the formula. Half-life is given you. Right, convert it to second times 60. Then you get per second. How to determine the activity?
A equals under N equals NO and A. Our Welsh constant.
First calculate your N. No? We calculate a lambda. Calculate the number of fluorine atom. Right? 18 gram contains that. So 2.1 times 10 to the power minus 12 kilogram contains, divided by 0.018 kilogram times 6.02 times 10 to the power 23, you get number of atoms of fluorine. Then A equals to N lambda. N is that, lambda is that, and get your answer. Pound per second or becquerel. A small sample of fluorine is injected into the body, act as a tracer for use in medical imaging. Describe how the interaction of B plus particle with an electron in the body enables the formation of an image. You want to try? What is your answer?
Beta plus particle and electron annihilate and the
Okay.
mass is converted into energy.
Only. So they accept pair annihilation occur or any of these answer. Any of these answer from the marking scheme. Suggest why 110 minutes is suitable half-life for nuclide using a tracer in medical diagnosis. Yep.
Uh, yeah, I think like longer half-life exposes patient to harm.
2 mark. Make sure you got 2 point.
So the point. Like shorter one will decay before the test complete.
Okay.
You mentioned short and long.
For short half-life, sample would almost fully decay before the test is complete. So of no use. Longer half-life exposes patient to harmful or ionizing radiation unnecessarily. Or alternative is with a longer half-life, a large dose of tracer need to be produced detectable activity. Explain how redshift leads to idea that universe is expanding. Okay, I want to try without looking at your answer.
Because increase Redshift is the increase in observed wavelength.
First, explain redshift. What is redshift? 3.3 mark. What are the other points? First, explain what is redshift. Redshift is the increase in observed wavelength caused by Doppler effect. Radiation from distant galaxy is observed to be redshifted. Redshift provide evidence that galaxies are moving apart. Okay, these are the various answers that the examiner will accept. Stars in distant galaxy emit radiation. Total luminosity of the star in the galaxy is 1.90 times 10 to the power 36 watt. The emission spectrum of radiation containing a line X has at a wavelength of 658 nanometer. Radiation from galaxy is observed on Earth. The observed radiation has a radiant flux intensity of 8.442 times 10 to the power minus 16 watt per meter minus 2. In the observed emission spectrum, line X has a wavelength of 726 nanometer. Determine the distance of d of the galaxy from the Earth. What? Use this
Then use
formula.
L equals, yeah, F equals L.
Then subject your d. Subject your d, take the d across d squared there, f there, square root that, and put in your value. That's your L, 4 pi, and there's your f. Calculate out. Then go to formula sheet. That's what you can quote from the formula sheet. Right? V, you want to work with wavelength, take C across there. That's the observed there. That's the actual one. You have the actual one times the speed of light. Okay, mark yourself.
Okay.
Okay, how would the graph look like? Observation of many
Straight
galaxies.
line, with a quite a steep gradient, I'd say.
Cut the
Linear, constant,
v-axis.
but with a steep gradient.
We must have a way to understand what is happening. Basically, we are using this formula. So H naught is a constant. So V is proportional to directly proportional to this, so it's a straight line passing through the origin. Right? Line with positive gradient passing through the origin. Straight line with positive gradient. State the name of the quantity represented by the gradient of the line. Yep. What does the gradient represent?
The gradient,
There,
wait,
the gradient. Right? Hubble constant. Okay. Let us go to the next year.
series.
Okay, October, November 2024, paper 42. Metal, have you found the paper?
Paper 4. Yeah, paper 4 2. Okay. Yep. 1 minute.
November lah, 2024. Okay, a metal wheel consists of an axle, that's the axle, a spoke, and a rim, that's a rim, as shown in figure 1.1. Point X is on the rim at the end of one of the spokes. So it looks like sometimes there are two questions, one circular motion, one gravitation. These days, last time circular motion hardly come out once a long time. Okay, the rim has a radius of 0.85 meter. The wheel is rotating clockwise with an angular speed of 140 radian per second. For point X, determine the speed. How to calculate the speed?
Uh, V equals omega R. So
Uh,
140 times
that's
0.85.
all. V equals R omega. Put in your value. Good. Calculate out. How to calculate centripetal acceleration?
AC equals V squared over R.
That's all.
110. Yeah.
A equals, as long as you can quote the formula that can calculate it, A equals to R omega square. R is 0.8, 0.85. Then omega 140 square. So that's your answer. 1.7 10 to the power 4 meter per second minus 2. There is a uniform field, magnetic field of flux density 0.818 Tesla into the plane of the page. State Lenz law of electromagnetic induction. Okay. It looks like from 2024 to onwards, Lenz law is coming out again now. Hall effect, 2023.
Direction of induced EMF is such as to produce effects that oppose the change that caused it.
Direction of induced EMF is such as to produce effect that oppose the change that cause it. Memory work.
That means the negative sign, is it?
No need to worry about negative sign. Negative sign is Lenz law. Okay. Show that the time taken for point X to complete one revolution is 45 minutes per second. Go to your omega. T equals 2 pi over omega. Put in your omega and get your answer. Calculate the magnetic flux by the spoke AX during one revolution of the wheel. Give a unit for your answer. Right? Phi is BA, or magnetic flux is B times A. Right? B is 0.18. 0.18. Area is pi. Is area squared out by the radius by the one of the spoke. So it's pi 0.82 square. What's the unit?
The unit?
What's the unit?
This is what?
Weber.
Oh, Weber.
Magnetic flux
Oh, yeah, yeah. Oh my God,
Weber.
I keep forgetting.
Usually, I ask you to calculate magnetic flux first, then after that, EMF. Determine the magnitude of the electromotive force induced in the spot. Right? And calculate the time for one revolution and calculate magnetic flux. So it's a magnetic flux divided by time. Don't worry about negative sign. Negative sign is Lenz's law. Then substitute. Supposed to be d phi dt lah. But since they want to avoid calculus, Cambridge want to avoid calculus, you can simplify the equation. Right? Phi is 0.411 revolution, 0.045 second, 9.1 volt. Use Lenz's law to explain whether the potential is higher at A or NX. That's your X, that's your A. How to explain? Can?
Yeah. This question wait. Question I didn't really do that.
Okay, you are told that it's clockwise. That's the force or the motion. So Lenz's law will tell us that it's anti-clockwise. So opposing force is anti-clockwise. So then applying a Fleming's left-hand rule, right? The field is going in. The force is anti-clockwise. The field is going in. The force is anti-clockwise. Field is going in. Force is anti-clockwise. Okay, Ken, where is the direction of the current? Or which part is at higher potential? I remember.
Current is from A to X.
Yeah, we're looking into a battery, not outside the battery. EMF. Force on the spot must be anti-clockwise. So the current is from A to X. A to X. From Fleming's left-hand rule. So X is at a higher potential. From A to X. It's inside a battery, so X is at a higher potential. Okay, happy with that? Any comment?
Okay.
Okay, let's go to number 2 then. The sun may be considered as a uniform sphere with a mass of 1.99 times 10 to the power 30 kilogram and a surface temperature of 5,780 Kelvin. A probe with a mass of 2.63 kilogram move in a straight line towards the sun. When it is at a distance x from the center of the sun, the probe measures the gravitational field strength G due to the sun and the radiant flux intensity F of the radiation from the sun. Define gravitational field. Then
Force per unit mass.
force per unit mass. For the position of the probe at x equals 1.47 times 10 to the power 11 meter. Calculate G. What formula to use?
GM over X square.
Gm over x square. And put in your value. That's your value for G. That's the mass of the sun. Mass of the sun. X. That's your x value. Square that. Then use calculator to calculate. Stop me, if you need further explanation. Determine the gravitational potential. What formula to use?
So must put a minus GMM over X.
Or go to the formula sheet, minus GMM over R. Right? Put in your G is 6, mass of the sun, mass of the probe, distance, then you get minus 2.37 times 10 to the power 9 joule. Show that for any particular value of x, the numerical value of G and F are related by the formula, that one there, where M is the mass of the sun, L is the luminous intensity of the sun, and G is the gravitational constant. Right? Basically using these two formulas, then subject your x squared, cross multiply, put x, take the F down, then replace it inside here. Right? GM x squared becomes L over 4 pi F. Rearrange it, then we get our answer. We derive the formula. Now you are apply it to the graph. Figure 2.1 shows the variation of G with F. Determine the value of luminous intensity of the sun if you need for your answer. Rewrite the equation.
4 pi GM over G.
Then this is the gradient or the slope S. So L is cross multiply. S, take it down. 4 pi G. This is your M. This is the gradient. Okay. As I say, easiest to read from here. Right? Upside down. Gradient. What's the unit for L? Yep. What's the unit for luminosity?
Watts.
What? Good. That's all. Use your answer in C part 2. Determine the radius of the sun. Right? Look the formula sheet. Can remember so much the better. If not, look for formula sheet. Right? Rewrite the equation. Put in your value. Rewrite the equation. Put in your value for luminosity. 4 pi. This one, look in the data sheet there. Or sigma. Stevens constant. And then the temperature. Okay, any comment?
Yeah, okay.
They try to combine two topic together lah, to show you the application of physics, gravitation and astronomy. Define specific latent heat. Okay. How to define specific latent heat?
Thermal and G needed to change state of the substance at constant temperature. Thermal
energy per unit mass to cause change of state at constant temperature. But this contain 7.2 times 10 to the power minus 3 meter cube of substance rests on the laboratory bench. The substance initially a liquid of density 710 kilogram meter minus 3. Most pressure is 1.0 times 10 to the power 5 Pascal. The liquid is heated at its boiling point, so that it completely vaporizes. The increase in internal energy of the substance during the process is 17.6 kilojoule, right? This is the internal energy. The final volume of the vapor is 0.17 meter cube. Show that the magnitude of work done on the substance when evaporized is 1.7 kilojoule. Complete the work done. No? P delta V, that's your P. And volume there, right? From the initial volume there, subtract that, and get your answer 1.7 kilojoule. Use your information in B part 1 to calculate the thermal energy Q in kilojoule supplied to the substance to cause it to vaporize. Right, go to your first law of thermodynamics. You want to calculate your Q, take your W over, right, 17.6, that's the internal energy. Work done, right, it evaporate, so there's work done by the gas, so that's why there's a negative sign there. Negative, negative, one positive, 19.3 kilojoule. Use your answer in B part 2 to determine the value of the specific latent heat of vaporization. Right, we have to
Well,
complete the
because
math. So your AS work formula have to be remember 10.10
B plus
and your volume, right? That's the density. That give you the mass. Then latent heat of vaporization is Q divided by M. Q was calculated previously. M, there's your M. Okay, any comment?
okay.
Substance B has a latent heat of fusion LF. Suggest and explain whether LF is likely to be less, the same, or greater than the answer in B part 3. Yep. You want to try to explain? Got 10 more minutes.
Molar change. Yeah, fusion.
Can
I'd say like LF is less than
why?
LV
Why?
because smaller change in intermolecular spacing. So much smaller change in internal energy.
Fusion involves much smaller volume change than evaporation. That's your first point. Smaller change in intermolecular spacing. So smaller change in internal energy. That's your second point. So negligible work done by substance during fusion. So LF is less than LV. Okay?
Okay.
Say three basic assumptions of kinetic theory of gases. Okay? See whether you can remember it.
Random, they move randomly.
First point.
It's not ideal gas.
Ah, what?
Wait, no, this is not ideal gas. So wait, sorry. Wait, intermolecular forces negligible. Like except during collision.
The point? Molecules are in constant random motion. That's the first point. All
Okay.
conditions between molecules are perfectly elastic.
Oh,
No
perfectly
forces.
elastic.
Perfectly elastic. No,
Oh yeah.
no forces
I
between.
thought that's for ideal gas.
That is the assumption for ideal gas.
Oh, but this
Kinetic theory is
kinetic.
basically we are looking at ideal gas.
Oh, oh. Oh, okay, yeah.
No forces between
Oh,
molecules except during collision. Right?
yeah, they word it differently, yeah.
Ah, we are looking at ideal gas when we consider kinetic theory. That's why we have to impose certain condition or certain assumptions.
Hmm.
These are others. Volume of molecules is negligible compared to volume of the gas. Collisions involving molecules are instantaneous. Explain how molecular movement cause pressure exerted by the gas. Okay, have a go.
Oh, mole- the molecules collide with the wall, the container, and rebound. Momentum changes. The momentum changes are causing a change in momentum.
Molecules collide with the wall or container. That's your first point. Momentum of molecule changes during collision with the wall.
Which also causes pressure.
So the change in momentum is caused by a force on the molecule by the wall. So the rate of change of momentum per unit area is the force, the pressure. Okay, so since they give 3 points, you can choose any of these 3 points. Okay,
Hmm.
figure shows variation with thermodynamic temperature of the mean square speed of two gases X and Y. Okay, no, roughly lah, the theory involved lah, right?
Yep.
Get the equation on a straight line, then rearrange a formula to get what you want. Gas are ideal, right? This ideal gas equation, right? Kinetic theory of ideal gas molecule, kinetic energy of a molecule of a gas. Right? First observation is gases are ideal. Then the gradient, KT is the gradient, right? Gradient you can calculate for X or Y. So gradient for mx, mass of mx, right, is you calculate for x. So take that across there, take this one down, take this one across there. There's your K value. There's your 3. There's your 400. So you get 3.3 times 10 to the power minus 27. You are supposed to observe on the graph and come to a conclusion. Then mass of one molecule of gas X, gas Y is double mass of one molecule of gas X. Okay, from there, the gradient, look at the gradient, same point there, roughly double. This one, roughly double. That's what he's saying. State 3 conclusions about the gases and their sample that may be drawn from figure 4.1 and figure 4.2. The conclusion may be qualitative or quantitative. Use the space below for any working. And we have done that. Conclusion. Right? The PV or NKT or PV equals nRT. Right? There's your gradient for this graph. And ny or y, sorry, is gradient over k. Gradient over k. Put this point there. Like 400. 2.7 times 10 to the power 3. Remember that don't forget. And then K from the data sheet, that's a K value. Sample Y contain triple the amount of gas or number of molecules of sample X. Right? Make sure you know how to calculate all this. My, sorry, there's some mistake here. Okay, these are other answer from the marking scheme that are acceptable. Okay, we got less than 1 minute. So see whether we can start or not. Figure 5.1 shows a pendulum consists of a metal sphere suspended by a thin string. The sphere undergoes small oscillations about its equilibrium position. The oscillation may be considered as simple harmonic. Figure 5.2 shows the variation with time t of the displacement x of the sphere from its equilibrium position. On figure 5.1, that's your figure 5.1. Draw an arrow from the center of the sphere to represent the direction of the resultant force acting on the sphere when it is at the position shown. That's all.